It appears as a small glowing ball that crosses the sky each day. Its heat warms us. Its brightness lights up the world and cheers us up. That's what many of us think of it, but appearances can be deceiving. What looks so calm and peaceful from Earth is actually a raging inferno where internal temperatures reach millions of degrees and violent eruptions leap far into space. It is huge, more than 100 times bigger than our Earth. It is the most awe-inspiring and fearsome object in our solar system. And while life on Earth could not exist without it, it is both deadly and destructive. It is, of course, our amazing sun. The night sky is filled with countless points of light. And with a powerful telescope, you can see billions and billions of them. They're stars, gigantic balls of hot, glowing gases that are scattered in unimaginable numbers throughout the universe. There is one star, though, that you don't see at night. Our sun. That's right, our sun is actually a star. Like all stars, it was born when vast clouds of cosmic gas and stellar dust collapsed on themselves. As the material collapsed, it got thicker and hotter, triggering nuclear reactions that continue to this day. The sun has been burning now for 5 billion years and is expected to burn another 5 billion years. It is an average-sized star, made up mostly of hydrogen and helium gas. The reason it appears so much larger than other stars is because it's so much closer to the Earth. The sun is responsible for all life on Earth. Its light enables plants to grow. The plants are eaten by animals, which are in turn eaten by other animals. Without the sun, there would be no weather, no day, no night, no seasons, no world as we know it. The sun is so important that ancient peoples worshipped it as a god. Ancient Native Americans of the Southwest built an observatory high above their pueblos from which to track the sun. It told them when to plant and harvest crops, and when to hold their festivals and ceremonies. To the Egyptians, the sun was the most powerful god, and was worshipped above all others. Its likeness was found throughout Egyptian art. The great Greek thinkers like Aristotle realized that the sun wasn't a god at all, but a heavenly body like the moon and the planets. They pictured a universe in which the Earth was situated at the center, with the sun revolving around it. And that is what people believe for nearly 2,000 years. It wasn't until 1543 that Nicholas Copernicus, a Polish astronomer, realized it was the Earth which revolved around the sun. Copernicus presented a model in which the sun was at the center and the planets, including the Earth, revolved around it as part of a system that we know today as the solar system. The planets of our solar system revolve around the sun, following nearly circular paths called orbits. Everything is held together by the pull of the sun's enormous gravity. Gravity is a force that attracts objects to each other. Gravity is what causes things to fall to the Earth. If it weren't for gravity, thrill rides would not be so thrilling. Earth's gravity is very strong. It's strong enough to keep our moon revolving around us. Without gravity, our moon would fly off into space. The sun's gravity is even stronger. Without its pull, all the planets would fly off into space as well. Instead, They follow orbits they've been following for billions of years. The Earth is the third planet from the Sun, following an orbit that keeps it an average distance of 150 million kilometers away. It's perfectly located, neither too warm nor too cold. If it were as close as Venus, the next planet in, our oceans would boil away. If it were as far as Mars, the next planet out, our Earth would be a cold, barren wasteland. From Mercury, the innermost planet, the Sun fills the sky and temperatures can exceed 400 degrees Celsius. As far as stars go, the Sun is pretty close, but it's still a long way away. If you could drive a car to the Sun, it would take you more than 175 years. While the Sun may look like a simple burning ball, there's a lot going on inside it. The inside of the Sun is made up of several layers. At the center is the Sun's core, which is made up of thick, heavy gases. This is the Sun's furnace, where nuclear reactions produce all the Sun's energy, and temperatures can reach 15 million degrees Celsius. The nuclear reactions that occur in the Sun are similar to those that occur during a nuclear explosion here on Earth. But the nuclear reactions that occur in the Sun's core are comparable to billions of nuclear bombs exploding every second. As heat and light move out from the core, they reach an area called the radiation zone. Here, the gases are somewhat cooler than those found in the core, but they're still plenty hot. Above the radiation zone is the convection zone, where temperatures are cooler still. This area is made up of large cells of rising and sinking gases. The gases rise and sink in the Sun's convection zone in much the same way that rice rises and sinks in a liquid when it is boiling. Above the convection zone is the Sun's surface, called the photosphere. This is the layer of the Sun that we can see. Here, temperatures can reach 4,600 degrees Celsius. Images taken through powerful telescopes show that the photosphere is made up of cells of circulating gases called granules. The granule pattern is continually changing as new granules rise up and push aside old ones. The granules may look small, but each one is larger than the state of Texas. Surrounding the photosphere is the Sun's atmosphere. The lower layer of the Sun's atmosphere is called the chromosphere. This rose-colored region extends about 2,000 kilometers into space. The outer layer of the Sun's atmosphere is called the corona. This region extends millions of kilometers into space. The Sun's surface is so bright that the only time you can see the Sun's atmosphere with your eyes is during an eclipse. That's when the Moon comes between the Sun and Earth, blocking the Sun's light and casting a round shadow that moves across our planet. This is what an eclipse looks like from space. And this is what one looks like from Earth as the Moon gradually moves across the Sun, blocking the light of the photosphere and revealing the Sun's chromosphere and beautiful corona. Total solar eclipses are rare, and ancient peoples were frightened by them. In some cultures, the people thought the Sun had been swallowed up. Today, we know that eclipses aren't frightening at all, and people travel great distances to see such exciting and beautiful events. You would expect the Sun's atmosphere to be much cooler than the surface, but it is not. It is many times hotter. Gas particles in the corona can reach nearly 2 million degrees Celsius. The corona is so hot that the sun's gravity cannot hold on to it. Parts of it escape into space, creating what is referred to as the solar wind. This is a high-speed flow of electrically charged gas that flows from the surface of the sun to the farthest reaches of our solar system. When we look at the sun, we see only its visible light. This is the light sometimes used by astronomers to study the sun. Visible light can be good for seeing things on the sun's surface, like sunspots, for example. But the sun also emits other types of light rays, including X-ray, infrared, and ultraviolet. While we can't see this light with our eyes, it can be seen by special instruments that scientists use. Scientists will sometimes assign false colors to images in order to see certain features better. This is the sun seen in extreme ultraviolet light in red, green, and blue. Each color tells scientists something different about the sun. Scientists will sometimes place a disk in front of the sun to block out the photosphere, in much the same way the moon blocks it during an eclipse. This enables scientists to study the corona without having to wait for a total eclipse. Magnetograms help astronomers detect magnetic activity on the sun's surface. The darkest and brightest areas are sunspots, which have a lot of magnetic activity. No one method is better than another. Each simply shows a different face of the sun. Scientists will choose which method to use depending on what part of the sun they want to study. Areas of special interest to scientists include sunspots. These are dark areas on the sun's surface. They were observed by the famous Italian astronomer Galileo Galilei in the 17th century. Galileo realized they were part of the sun's surface and made detailed drawings of them, but he didn't know what caused them. Today, we know they are violent magnetic disturbances in the sun's photosphere. They appear dark because they're cooler than the rest of the sun. Sunspots look small compared to the rest of the sun, but they are actually quite large. Large sunspots can be many thousands of kilometers across. This is about how big the Earth would appear next to these sunspots. The sun spinning makes sunspots seem to move across its surface. Sunspots can last many weeks, and you can measure the sun's spin by keeping track of their movement. This sequence has been greatly speeded up. In actuality, the sun spins once every 27 days. You can see sunspots yourself, but whatever you do, don't look directly at the sun. It could permanently damage your eyes. Instead, you can use a pinhole projector like this one. All it is a tube that has a tiny hole at one end and a viewing slot at the other. You just aim the hole at the sun, and its image will be projected into the bottom of the tube. If there are sunspots, you should be able to see them. Sunspot activity increases and decreases during 11-year cycles. The movie on the left shows the sun during solar minimum, a period with few sunspots and other solar disturbances. The movie on the right shows the sun during solar maximum, a period with many sunspots and solar disturbances. Sunspots are sometimes associated with enormous formations called prominences, which rise hundreds of thousands of kilometers above the sun's surface. They seem to resemble fiery fountains and can remain suspended in the sun's atmosphere for months. But sometimes they can suddenly erupt, spewing gases and energy millions of kilometers into space. Many prominences, like this one recorded in 1946, can reach enormous sizes. Our Earth would be dwarfed by these gigantic eruptions. Other solar eruptions include coronal loops. These are arching fountains of super-hot electrified gas that rise up from the sun's surface. Coronal loops play a key role in heating the sun's corona so that it is 300 times hotter than the surface. Sometimes there are sudden releases of energy on the sun that show up as bright flashes in the upper atmosphere. These are called solar flares and can last anywhere from a few seconds to many hours. The energy released in a solar flare is equal to 10 million volcanic eruptions. As with prominences, when there is a lot of sunspot activity, there are a lot of solar flares. Solar flares can be so intense that they can cause sunquakes. These are waves of energy that move out in circle-like patterns. As big as solar flares are, there are even bigger eruptions, called coronal mass ejections, or CMEs. These are made up of material that has blasted millions of kilometers into space. CMEs disrupt the flow of the solar wind and create disturbances on Earth. Erupting from the sun, CMEs travel at speeds of up to 3 million kilometers an hour. When they reach the Earth, they bombard our planet's magnetosphere, an invisible magnetic shield that surrounds the Earth. Material in the CME is deflected and follows magnetic field lines all the way to the Earth's poles, where it collides with gases in the atmosphere. The result is an aurora, curtains of shimmering light that seem to dance across the polar night sky. Unfortunately, auroras aren't the only result of CMEs. They can also damage power stations, interfere with radio transmissions, cause massive blackouts, and can damage and destroy satellites orbiting the Earth. They could even kill astronauts working outside the protection of the space shuttle or space station. Solar activity can even affect our weather and climate. 500 years ago, the world was much colder than it is today. Colder temperatures are shown in blue in this model. But over the centuries, the world has gradually warmed. Warmer temperatures are shown here in red. Some scientists think this is at least partly caused by changes in solar activity in addition to other reasons. As evidence, they point to the 17th century when there was a little ice age in Europe. The winters were much colder and lasted much longer. Rivers that never froze before froze solid. This happened to occur during a period of unusually low solar activity. There is even more evidence that solar activity affects global warming from this century. This chart shows the increase in temperatures the Earth has experienced in the past 100 years, and this shows the increase in solar activity. It appears to suggest a connection between global warming and solar activity. No one knows for sure just how much solar activity affects global warming, and this is just one of the reasons why scientists want to learn more about the sun. The sun is constantly being watched from solar observatories like this one throughout the world. Powerful telescopes have been used to observe the sun for more than a century, and they continue to make important discoveries. But from these observatories, astronomers are unable to make observations on cloudy days and at night, and even on clear days, viewing can be distorted by our thick atmosphere which surrounds our planet. That's why organizations like NASA and many others launch satellites and solar observatories into orbit to get unobstructed views of the sun. In space, there is no night, no clouds, and no atmosphere to interfere with observations. One such satellite is SOHO, the first observatory to explore the Sun from the farthest reaches of its atmosphere to its hot interior. One of SOHO's important jobs is to study the Sun's effects on the Earth. That's why it studies the solar wind, monitoring the particles as they blow past. It is hoped that the information gathered by SOHO and other satellites will lead to an early warning system that will detect CMEs before they occur, providing us much earlier warnings of these dangerous events. Other satellites are aimed at the Earth itself to help monitor the Sun's ultraviolet rays that strike our planet. UV rays are harmful to people and cause severe sunburn and even skin cancer. Some parts of the world, especially areas near the equator, receive high levels of UV rays, and people living there should avoid prolonged exposure to the sun. UV levels are highest in North America in the summer. Scientists also hope to unlock more of the sun's mysteries in order to learn more about its inner workings. What causes sunspots? Why do they occur in 11-year cycles? What causes the solar wind? In what other ways does the sun influence our climate and environment? These are just a few of the many questions scientists hope to answer in the years ahead. In this program, we've learned that the sun is actually a star and appears much larger than other stars because it is so much closer to the Earth. It is the center of our solar system, and all the planets, including our Earth, revolve around it. The sun is a large gas sphere made up of mostly hydrogen and helium. The inside of the sun is made up of several layers. At the center is the core. This is where all the sun's heat and light is produced. This is the hottest part of the sun. Outside this is the radiation zone, which is somewhat cooler than the core. Above this is the convection zone. This is where gases continually rise and sink. Outside this is the photosphere, the sun's surface. This is the layer of the sun that we can see. The photosphere is made up of cells of circulating gases called granules. Surrounding the photosphere is the sun's atmosphere, which is composed of an inner layer called the chromosphere and an outer layer called the corona. The solar wind flows from the surface of the sun to the farthest reaches of our solar system. Sunspots are magnetic disturbances in the sun's photosphere and appear as dark spots. Prominences are formations that rise thousands of kilometers above the sun's surface. Coronal loops are fountains of super-hot electrified gas that rise up from the sun's surface. Solar flares are sudden releases of energy that show up as bright flashes in the sun's atmosphere. Coronal mass ejections, or CMEs, are immense eruptions in which particles are blasted millions of kilometers into space. CMEs disrupt the solar wind and create disturbances on Earth. Scientists want to learn more about the sun and observe it from ground-based telescopes and orbiting observatories. The more we discover about the sun, the more we learn about our planet Earth and its unique relationship with this, our closest star.